So in this media, we'll discuss about boiler refractory, its purpose and reason of failure, what are the types. So this was a separate question by the surveyor altogether. I have tried to compile this from different sources. We'll just go through it. This is in a very simple words. Wherever required, we'll stop and elaborate. Now, what is the requirement for your boiler material is that it should contain the heat generated in the furnace. So it should be able to insulate, means it should be able to contain the heat which is generated in the furnace, because that heat should not be, there will be losses, but it has to be minimal. They must therefore have good insulating properties and should be able to withstand the high furnace temperature to which they will be exposed without deteriorating. They should have sufficient mechanical strength to resist forces set up by adjacent brickwork. Should be vibration resistant. So what are the this? They should be able to contain the heat generated. So we have good insulating properties. So they should be able to withstand the high furnace temperature. Mechanical, they should have mechanical strength, forces set up by mechanical strength to resist forces, vibration resistant, to expand and contract without cracking, okay, because in cold and then heating, so it will be expansion. And refractory material to be chosen according to the duties they will face. Okay, now what are the three main types of refractory? Acidic refractory, example clay, silica, quartz, sandstone. They are not affected by acidic material by react with basic or alkaline materials. Neutral refractory, example we say is chromite, graphite, alumina. These are used in areas where slag and atmosphere are mostly acidic or alkaline, as they are neutral to both. Alkaline refractory, example is lime, magnesia, zirconia. Fire brick, these are formed into bricks and then fired at high temperature in special mills. Monolithic refractories are supplied in an unfired state, installed in the boiler and fired in situ when boiler is put in service. The form of refractory can be subdivided into, so they are divided into three other categories, that is moldable refractory, used where direct exposure to radiant heat takes place. It must be pounded into place during installation. Castable refractory is placed behind water walls and other parts of the boiler where it is protected from direct exposure to radiant heat. It is installed in a similar manner to building concrete. Plastic chrome ore is bonded with clay and used in the construction of studded water walls. It can resist high temperature but has little mechanical strength and is pounded onto steel studs welded to the tubes. These studs provide both strength and means of attachment for the refractory. Now, it should be noted, when choosing suitable material, care should be taken to ensure acidic and alkaline materials are kept apart, as at high temperature they can react to form salts which destroy the effectiveness of the refractory. Refractory failure can render a boiler inoperative, as the heat and combustion gases will not be contained in the furnace in single case type boiler. To prevent undue stresses being set up in the refractory, ample expansion spaces, so this is important, must be provided. Care must be taken that these spaces do not become blocked, as this can cause the refractory try bulge out and break away from its attachments, with dangers of possible collapse. The common trouble in boiler furnaces are, what are the problems that we are facing? Spalling, slagging, shrinkage, cracking and failure of brick, okay, securing devices. Now what is spalling? Spalling is the name given to the breaking away in layers of the surface of the fire brick. So in fire brick they get break up in the layers when it is subjected to high fluctuating temperature under flame impingement condition. If cold air from the FD fan is allowed to impinge on hot refractory surfaces, then the condition may occur. It can also occur in monolithic linings when they have been saturated during water washing of the superheaters, etc., and fired too quickly. Slagging is in effect a softening even up to liquid state of the surface of fire brick. This can occur when sodium in some form being present at high temperature brick surfaces, either from ash produced by burning fuel contaminated with seawater. This sodium acts as flux and lowers the melting point of fire brick. In extreme cases, the semi-molten refractory run down the wall, resulting in eyebrows above each burner quarrel due to ingress of cooler combustion air. Once the fixing anchors are exposed, then they too are burnt due to exposure, causing complete collapse of wall and buildup of semi-molten material on the floor. Shrinkage cracking. Shrinkage cracking refractories are generally weaker in tension than in compression or shear. Brickwork is in compression at high temperature, and when suddenly cooled, then high tensile stresses are set up due to contraction causing shrinkage cracking. Failure of brick securing devices. The anchor bolts are exposed once the fire bricks crack due to restraining action of the bolts. The bolts will overheat and fail due to exposure to the high furnace temperature, resulting in weakening the brick wall and lead to collapse. So these are the different refractory problem that they are occurring and what are the reasons for them. So these are self-explanatory. I have tried to make notes in a very simple and lucid manner for you to understand. My idea is not to teach you, my idea is to bring the expected answers under one umbrella so that it becomes easy for all of us to refer. Okay, bring all the content under one umbrella. Thank you so much. Thank you for your valuable time. All the very best for your future endeavors.